Hello, dear student. Welcome to another lecture on programming in C++. In the previous lectures, we have seen what are the important features of C++, how can we write a C++ program. We have tried writing some of the C++ program and we have defined some of the input-output characteristics of C++. In this video, we will be learning about data types, that types of data in which we can input and get output from the C++ program. We will be looking into variables and constants used in C++. How can we define a variable? How can we define a constant and all? And we will go into the manipulators. Then manipulators are functions used to manipulate the output we get. And we will look into some of the main manipulators used in C++ also. Now, data types. Data types refer to different types of data in which we can access C++, in which we can give data and extract output from C++. There are different types of data we can use in C++. It can be an integer, it can be a character. A character is a alphanumeric or a special character like a star or hash. It can be a boolean. Boolean is a function which have an answer yes or no only. It can be a floating point. We have discussed about floating point in the last program. We have done it with int and also float. Hope you remember. You have done with the floating point. Floating point is a number which has a decimal part also. Now the data can be a double floating point. It can be a void. Void means nothing. It can be a character. It can be a white character. Also, there are different derived data types such as function, array, pointer, reference, etc. We will come to this towards the last of the this program. And there can be many user-defined data types such as class, structure, union, types of etc. A number such as say number 23 can be entered into the C++ using the data type integer, that is int. Again, if the number is 23.256, then it should be a floating point. If there are many decimal points, then it should be a double floating point. In the same way, if you want to enter a word, say a name, say Rejeena, then you have to use a data type which is string or wide character. If you have to enter a special character or a single letter, then you have to use the data type character. Data types differ from the variables we have to use. We choose the data types accordingly so that our memory space is well used and well allocated. Data types are used while we declare a variable. We have seen variable declaration in our last example where we have declared int ab in our last example, and I have said that a and b are variables and we have to define the variables before we use it. So while a variable declaration, we specify which type of a variable it is. If it is an integer variable, we declare the variable as int a. We will look into the variable declaration now. Now this is different types of data types, their meanings and the size of the data. Size of the data are usually given in bytes, and some examples. The first example is integer. You are very familiar with this and we have done a lot of example using integers. The data type is int and it have 2 to 4 byte size. For example, int salary is equal to 85,000, where salary is a variable and int is the data type. Float. Floating point is a number which has exponentials, a number which has a lot of decimal points. It can be considered as a float and it have a higher size, that is 4. There can be double floating point with a much higher size of 8 bytes. There can be a character. Character is a data type which is referred in single quotes. Say character test is equal to H, where H is given in the single quote. There can be wide characters where we can give a lot of characters such as P, H, Y, S, I, C, S can be given in the same line, and we can extract the output. If we need to extract a output, not just a letter but a group of letters, then we use the data type wide character, or we can use string for the same. Another data type is Boolean. I have already said Boolean has only two possible values, that is true or false, or yes or no. So Boolean are used in the conditional statement loops to take logical decision, and the way it is written is Boolean condition is equal to false. It have only 1 byte size. Another data type is void, that is nothing is there, it's empty, so it have 0 size, and no variables can be declared using void data type. There can be string. We use string to give data or extract data which is a long alphanumeric. Then we will use the word string. We have already used the string in Hello World. We have used string in Enter Your Name in our previous programming videos. So a string has a much larger size and it have 8 byte size. We have said that data types are used while declaring variables. Variables are some of the numbers we use in C++, some of the numbers or alphanumerics we use in C++ to define some of the variables which doesn't occur in the standard form. We have done in the previous videos itself. We have declared A, B, sum, etc. as variable and taken them as variables also. Yeah, in this case, we have to define a variable. We have to declare a variable before using it. And the variable declaration comes as the data type, the variable name. For example, if int A or int B, then int is the data type which shows that the variable A is an integer, and we declare the name of the variable as A. We can also declare variable with an initial value such that int A is equal to 100. That is, int is the data type, A is the variable name, and 100 is the value. Variable name is also called an identifier. An identifier is a variable name, and all the variable names have to be unique, and it shouldn't be some of the standard forms. So there shouldn't be two variables with the same name. So we call it as an identifier because we need to identify that variable using that name. There are different rules in which we have to name a variable. A variable can have only alphabets, numbers, and underscore. The variable name cannot begin with a number. The variable name should not begin with an uppercase letter, uppercase character. A variable name cannot be a keyword or a standard word such as int, delete, while, if else, new, public, string, etc. A variable name can start with an underscore, but it is not a much promoted idea. Before going into constants, I think we shall look into some of the examples for variables. Here I have a program, hash include iostream, using namespace standard, and int main or main is also okay. I have already said int main is not gonna server purpose right here. So we will go with first variable. Say I declare a variable here. I declare a variable int a. Here int is the data type and a is the name of my variable. And I can define my variable as, say, set a is equal to 100. Now what I have done is I have saved the number 100 into my variable a. Now if I see out my variable a, then it comes to be 100. Now again, if I define my variable a is equal to 200, then I have saved the number 200 into the variable a. Now 100 is replaced with 200, and see out a. Let me give an enter here so that two numbers will appear in the in separate lines. Hope you are much familiar with int l. We have used it to use int l. Since I have saved my first number 100 into a, then the cout will give 100, and in the next step I have saved another number 200 into my into my variable a. So I will get a number 200. This is the way in which a variable can be declared and the variable can be given values inside a main function. I can do the same while declaring the variable itself. For example, if I do not want to change my variable value occasionally, then I can give the value initially when the variable is declared, and this type is called initialization of the variable, and this will give you an output a is equal to 100. I need not write int a here and in the next line a is equal to 100. I can give the value along with my declaration, and that is called initialization. Hope you are clear with the variables. Now we will go on to the next, that is constants. There are different types of constants we use in a C++ program. It can be a string, it can be a numeric, or it can be a character. I've already said string is a long alphanumeric with spaces we use. A numeric can be an integer, a floating point, a hexadecimal, or an octal number. String is usually defined inside a double quote, say hello world. Numeric is defined as it is, say int xy or long int xy. Character is usually defined inside a single quote, such that in the last slide we have seen that the character is defined here as character test, which is inside a single quote. So character is defined inside a single quote. Some of the characters can be defined outside a single quote also. Some of the characters we use, or the manipulators, again is within the single quote, is \t or \v, that is a vertical tab, /t is a horizontal tab, or a /new line can also be used as the constants. A constant is used when we have to set a value which cannot be changed. For example, in the last video we have seen, in the last slide we have seen, in the last program we have done, we have said that we use a variable there a is equal to 100 with an initialization. Say without using a is equal to 100, while defining a variable, I can say it's constant int is equal to 100 or constant int a is equal to 100, then I may not be able to change the value of the variable. In the last program we have seen we have changed the value of variable a from 100 to 200 because it wasn't a constant, it was a variable. While declaring a constant we use the syntax const constant and the variable type, then the variable name, and is equal to the value. Variable initialization is also required at this constant declaration, and this constant value cannot be changed. Let's see how it comes. Without doing, I can use a word constant int a is equal to 100 and cout a. Run and see that it will give a cout. Now if I try to change the variable a is equal to 200, it will give me an error, that is a is a read only variable, that is I cannot change a. If we have to do something with a constant which cannot be changed, then we use this data type. Hope you're clear with the constant variable, the difference between the constants and the variable. Let's say, let's do a program to find the mass energy. Let's define a constant integer c. Mass energy is calculated as mc square. Let's c, who has a value 3e8. Now it cannot be an integer, it must be a float, because integer cannot hold 3e8. e8 means 10 to the power 8. So it should come under the data type float, because the 3e8 cannot be under an integer. Now another data type, I have to measure it again as float mass. Cout, enter the mass of the particle. Oh, it have to be inside a double quotes. Enter the mass of the particle. Let it end with an entel so that it will give me enough space, reading space. Cn is used with an extraction operator and cout is used with an insertion operator. Cn mass, I can type mass here because I have already defined a variable mass here without initialization, and float is the variable type, that is data type, and mass is the variable name or the identifier. Now cout energy is, let's say, calculate mass energy. Here I have to include another variable as energy, and energy is equal to m into c into c. Energy is energy. Since I haven't given int main, the return 0 is not needed here. If I've given int here, then I have to type another line return 0. Uh-oh, I have a problem here. M is not declared. Yeah, M is not declared. Mass is the only variable which is declared. See out mass energy. I've missed a semicolon here. Again. An extra semicolon here. It's ready to run. Enter the mass of the particle. Mass of the particle like 1.2 MeV. Then my mass energy is 1.08 into 10 to the power 17 MeV by C squared. So this is a way in which I can use a constant. This is a way in which constant is defined with a data type and the identifier and an initial value. I can define a variable with a data type and just the identifier, that is the variable, and I can use it all along. Now we will step into manipulators. Manipulators are special function streams which are used to manipulate how the output looks. So manipulators such as tab or vertical tab, as we seen in the last slide. These are all manipulators that we can manipulate how we look into the output, how the output appears. For example, we need a space between two of our outputs, then we will use a manipulator end L so that in our output screen we have a new line or a space between two of our lines, such that many of the manipulators are here. Manipulators, some of the manipulators such as end L or set W manipulators can be used just by calling IO string. But there are manipulators such as set base or set fill which come only under the header file IO manipulate, that is input output manipulate IOMANIP header file. So we have to call that header file to use these manipulators. And some of the manipulators are end L. You are already familiar with end L. End L is used to start a new line. There is end, a manipulator which is used to terminate a program or which is used to give a null character in the output. There is another manipulator set width, set W. This is used to set the width of the output. There is another manipulator set base. That is, we use all our numbers in decimal base, that is base to the 10. We can also use it with hexadecimal base or an octal base. For that we have to set our base. Another manipulator is set fill. Set fill is used when we set width. There will be width between datas. We will do some examples in these programs now in a short while. And set fill is used to fill that small space with some special characters such as a star or a hash. There is set precision, that is if I have an output which is 1.732 and I need it only to 2 decimal points, then I can set it into the precision which I want. Another manipulator is WS or white space. This is used to ignore the leading white space that precedes the first field. There is another manipulator flush which is used to empty the output string. Now let us look into some of the examples for the manipulators we have just discussed. First is set base. How can we set a base? Hope you are clear, already understood the lines such as hash include IO stream, using namespace standard, main, void main, int main, etc. And you are familiar with int value, that is a variable declaration. And we will see how we can use the manipulator set base. So here we're gonna use our manipulator set base. To use this, let me evoke the same function. Enter cout. Enter the number. We have now we are trying to enter a number and define the same number using three bases, that is decimal basis, hexadecimal basis, and octal basis. Hope you're already familiar with what hexadecimal, octal, and decimal basis actually means. These are bases we actually use in computer programming so that programming will go good. We have to define some variables here because we are using it. In number, can it be a number? Yeah. Now cin is used with an insertion operator, and I save the data whatever inserted as number, and I will save it into the cn, into the variable number. Now cout the decimal base. Decimal base. Now I set my base using the manipulator set base, or I can just type decimal also here, decimal, DEC, decimal is good. Without using set base, I can type decimal here and enter the number. Decimal base, hex number, enter cout octal base, oct number, and I'll see how it looks. No errors. Now let me enter a number, say 16. In decimal base it is 16, but in hexadecimal base it is 10, and in octal base it is 20. Try another number. Enter the number as 30. In decimal base it is 30, in hexadecimal base it is 1 into 10, and in octal base it is 36. So thus we can use the base set base, or without using set base also we can use it as hex, dec, or oct to set our base and change our base. This is one of the manipulators, output manipulators. So moving on to another manipulator, that is set width. I can set the width of my output. That is, I can set how much space I need to leave before my output. Let's find how to set width. And here I have used a program. I've initiated two numbers, a is equal to 0, a is equal to 100 and b is equal to 200. I've initiated two variables with initial values and counting the same variable with a different set width. Let's see how it appears. Now I have two variables, a and b. Either I can put it as a and b and set my variables as a is equal to 100 and b is equal to 200, or else I can initiate the same over here such that a is equal to 100 and b is equal to 200. These are steps we use to simplify how our source program would look. I can do the three step in one single step. This is the advantage of using initializers. Now we are trying to find how the set width, the manipulator set width work. So say cout set width as 6 A. Again set width as 6 B and L. Again cout. Here I set width as 7. What I'm expecting is I will get a 7 space or 6 space here. A. Let us see how the outcome will come. Set width again as 7 B and L. Try another line. Cout so that the difference will be much evident. Set width as 8 here. Set width as set width as 8 B, and I end the line since there is no int here, no return value. Oh, to use set width, I have said to use some of the manipulators, I have to call in another header file, that is IO manipulators. Some of the function will work only when I call this library file, because IO stream doesn't know what setw is. So we have to call in somebody who knows what setw is. Here we go. Here I have 5 spaces. Here I have 6 spaces. And here I have 7 spaces between them. This is how I can manipulate my outcome using manipulators. So hope you are clear with on what we use the set width. Set width is, again, we use it for something we need to set a space so that our outcome will look good. Now again, it is set fill. Instead of having free spaces there, I need something to fill it up, such that a hash or a star, and you know this hash and star all are characters. So character should come under a single quote. So let us see how set fill function will work. In the same function, I use it as cout set fill, and which is character. So character should come under single quote, and I need to set it with a star. Let's see, is there any problem with this? Set width. Here we go. We have set our width in the last program, so we have some free space here, but instead of having free space, we have filled that space, set fill that space with some special character, and that special character appears here along with how much space we have intended to. Here we have 3, here we have 4, and here we have 5 spaces, as we have defined it to be 6, 7 and 8 spaces. Hope you're clear with set width and set fill. Set width will give us blank space, and set width will fill that blank space with some special character we would enter into that. The next manipulator is set precision. Say I have to set my precision as I need my output to some precise value only, then I can set my precision. Let's do a program with a value of pi. Now I initialize my value. I know that value of pi is actually 22/7. So let a is equal to 22 and b is equal to 7. I need to initialize it as float, because my value which I'm gonna get is float. Without initialization, I have a value pi here. Now I have to define what is the variable. I have already defined my variable pi, so I have to tell the compiler what pi should do. So pi is 22. Pi is a divided by 7. 22 divided by 7 will also work, but we have already initialized a and b. Let it be a divided by 7, and cout pi. Semicolon. Let's see what happens. Here I have the value of pi with my floating points. I have 5 decimal points here. Now let imagine that I need only 2 decimal points. My output needs only 2 decimal points. Then I will use this term set precision. Let's see what happens. Cout set precision as 1. Oh. Compile. See, I have only 1 point here, 1 point. Now let us see what if I change my set precision count. Set precision as 2 pi. I need an enter here so that it will appear in different line. And L is also a manipulator. Try another cout also. change the precision. Change the precision to 3. Pi. Enter. Let's see what happens. I have pi value as 3. I have the pi value as 3.1 and I have the pi value as 3.14. Depending on how much I have set my precision, how much I can set how my output should look. These manipulators, all these manipulators are used to say the compiler how my output should look. My output should have some vertical spacing, my output should have some horizontal spacing, my output should have some special characters like star or hash. My output should only have some specific number of decimal points. All these things I can set and I can manipulate my output, so that these functions are called manipulators. By this we have came to the end of this lecture. See you in next lecture. Thank you. Hope you have already started doing C++ and you have downloaded DEV C++. I recommend you to do all these in C++ and see how your outcome will come. Thank you.